Hello students, welcome back to my channel, and today I am going to do class 12's the chapter vector algebra and the topic that is very known topic, and it's section formula. Well, section formula you already have done in 2-dimensional geometry and 3-dimensional geometry. So 3-dimensional geometry class 12 section formula part already I have done in previous sessions. So you can go and check the previous sessions. Links will be given over there. Coming to section formula using vector method. Okay, it's very important yet very easy. For this I am just drawing a line. Suppose its name is PQ. Its name is PQ. I'm taking its R. So we are going to find out R's position vector. Previously we had in 2-dimensional and 3-dimensional geometry P's coordinates, Q's coordinates, and then we have to find out R's coordinates. Here we will not find out R's coordinate, rather we will be finding R's position vector, whereas P's position vector and Q's position vectors are given. Okay, so we will start with that. Now we will be taking it as M, the internal division ratio. So this is the case 1 where R divides PQ internally in the ratio M is to N. Now as this is M and this is N, it is quite obvious that PR divided by RQ is equals to M by N. PR divided by RQ equals to M by N. Now from this, one thing we can write down, MRQ is equals to NPR. Now the whole thing, this is actually, I am just giving the arrow in the side from P to Q. The whole line is one vector. That means in the whole line unit vector will be same. So you just for a while you think about that we are multiplying both sides with the same unit vector. That means we will be getting M RQ vector is equals to M into PR vector. Magnitude into its unit vector gives us the vector. Magnitude into its unit vector gives us the vector. For just by using that we can write from RQ to RQ vector, from PR to PR vector. So this one, number 1 I'm writing. Okay. Now I'm just completing the figure. Think about that this is O, the origin point. OR is joint. Sorry. Suppose this is Q. OQ is joint. Okay. OP vector is the position vector of P. OQ vector is the position vector of Q. OR vector is the position vector of R. Now I'm just giving this name as A vector, this is B vector, and this one R vector. So we need to find out R vector's value. Okay, so I'm drawing this. I hope you all have noted it down. Still I'm writing over here once. It was M RQ vector equals to NPR vector, and this was number 1. Now I'm just giving this, I'm taking this particular triangle first. So triangle OPR. Use triangle law of vector addition. So vector addition's triangle law gives us A vector plus PR vector is equals to R vector. A vector plus PR vector equals to R vector. From this, we can write down PR vector as R minus A vector, right? Then I am taking the lower triangle, that is triangle OQR. From this, we can see that R vector plus RQ vector equals to B vector. R vector plus RQ vector equals to P vector. And it implies RQ vector is equals to B vector minus R vector. So we have got both the values of PR vector and RQ vector. Now we can replace these two values here in the first equation. So I am keeping the values here. So the first equation we are getting M into RQ vector. RQ vector means B vector minus R vector equals to N into PR vector. That means R vector minus A vector. From this, we can just simplify it. MB vector minus MR vector equals to NR vector minus NA vector. I kept telling it from the very first day of vector algebra chapter, don't miss or don't forget to give the vector sign. Okay? So we are just taking it, R vectors we are taking it one side and another two vectors we are taking it another side. So ultimately we are getting MR vector plus NR vector equals to MB vector plus NA vector. Okay. From this we can take R vector common and then we can write down I don't think that you can see it. Now you can see it. MB vector plus NA vector divided by M plus N. Now I hope this is actually the formula, section formula for internal division. Now you can see that already we have done this type of expression in 3-dimensional geometry and 2-dimensional geometry also. Look, M is this one here, M into far vector, that means B vector. M into far vector plus N into far vector, so far plus far divided by addition, same thing. So actually students, this is very simple. Already we have done this type of things in what? In 3-dimensional geometry and 2-dimensional geometry. I hope you have understood up to this. Now case 2. Now similarly we can prove case 2 also. So case 2 is what? Case 2 is section formula when a point divides a line externally. Okay, so this is case 2. Case 2 is external division. Okay, for this I am just taking it Think about this. Suppose this is PQ, sorry. Suppose this is P and this is Q. This is O. This one is R. Again in the same way, this is B vector. This is suppose A vector. This one is R vector. We have to find out again R vector's value, where PR is M and RQ is N. That means from here to here, this is N. So R divides the line PQ in the ratio N is to N, but externally. Okay. Now from this figure, again we can do the same thing. That is, from this you can see that PR divided by RQ is equals to M by N. From the same thing we can write down M RQ vector is equals to N PR vector. This way. Right? So this is in this way. Oh, sorry. Then this will be little bit change. It will be QR vector, not RQ. It will be QR vector. Okay. So this is QR vector number 1, and then you take this triangle and this triangle, the whole triangle and this smaller triangle. So first triangle OPR, and it gives A vector plus PR vector is equals to R vector. From this we can write down PR vector equals to R vector minus A vector. Triangle OQR is equals to B vector plus RQ vector equals to R vector. From this, sorry, not RQ, it will be QR vector. So it's QR vector equals to R vector minus B vector. So we have got both the values. We can now replace these two values here in the first equation. So from number 1 equation we can write M into QR vector, that is R vector minus B vector, N into PR vector, that means this R vector minus A vector. From this we can get the calculation as MR vector minus MB vector equals to NR vector minus NA vector. Okay, I hope you can see it. So both R vector we are taking in the left hand side, so we can take its common. That means M minus N R vector is equals to MB will be plus over there, so MB vector minus NA vector. From this we can get R vector equals to MB vector minus NA vector divided by M minus N. This one is the section formula for a line to be divided by a point externally. Okay, so this is the section formula externally and internally. Both we have discussed with a vector method. This way of doing it itself 2 questions, individual 2 questions. or together it also can come. So you need to understand the concept. Look, mathematics is not like that you can memorize everything, and special not in class 12 at least. So you have to understand it, and trust me, vector is very easy once you understand it, and at the same time it's very interesting chapter. Okay, so up to this I hope you all have got clear idea. So we will move on to the next topic. That is, the next topic is product of two vectors. Okay, so product of two vectors. Before I erase this, I will write over there and then again I am continuing. So students, product of two vectors are of two categories. Number one, this is scalar product. Scalar product. Precisely, we call it as dot product. DOT, dot product. The sign is dot like this. Okay, so it's dot product. And the second one is vector product. Vector product. And we call it as dot product and cross product. This is dot product and this is cross product. So this is dot product means its symbol is like dot, and cross product because its symbol is like cross. That's why its name is like that, dot product and cross product. Now first we will discuss everything about scalar product of two vectors or dot product of two vectors. So vector product or cross product we will be discussing later on. Okay. Now dot product, what means, which type of thing it is? First we need to know that two vectors A and B, scalar product of these two vectors is defined as A dot B equals to modulus of A into modulus of B into cos theta. What is theta then? Theta is the angle. Theta is the angle between A and B. Both the vectors. Theta is the angle between both the vectors. Theta will be 0 less equals to theta less equals to pi. Okay. In your book the figure is given. Still I am writing. I am drawing the figure here. Suppose this is A vector, this is B vector, this will be theta. Okay. Now if A equals to 0 or B equals to 0, both the vectors are not 0, either A equals to 0 or B equals to 0, then it is quite obvious that theta is not defined, right? Because theta cannot be constructed with a 0 vector. So theta is not defined. And in this case we can say that quite obviously A dot B equals to 0. Don't put 0 vector. A dot B equals to 0. Because if any one of them is 0, then this product obviously will be 0 because theta cannot be defined, cannot be drawn. And in another case also, suppose A and B both are 0 vector, then also their dot product will be 0. Okay. Now for both vectors 0, that is little bit different thing that we will be discussing. Now observations, okay? So according to this, there are some observations that should be noted down. We will be writing that. I hope your copies are ready with you. So observations. Number one, the first thing that I told, don't put vector sign on 0. Why? Because a vector dot b vector always is a scalar. And that's why its name is scalar product. Okay? So a dot b will always give us a scalar. That means a number, a real number. Number 2, a dot b will be 0 if and only if a vector is perpendicular to b vector. Why if and only if? Because vice versa is also correct. Means a dot b equals to 0 if these two are perpendicular, or if these two are perpendicular, then also a dot b will be 0. Here this particular property or observation, you can say, is valid for all non-zero vectors, because for 0 vector it is automatically 0, so we will not get this type of condition. So for this type of condition, to get this type of condition, we need a and b both non-zero vectors. Okay, then number 3, suppose theta equals to 0. What will happen? Theta 0, that means we will be getting a vector dot b vector equals to mod a vector mod b vector. Cos 0 is equals to 1, that means it is only 1, so this 1 need not be written. So we have got theta equals to 0, that means a dot b is equals to mod a mod b. Coming to number 4. Number 4 of, can you see number 4? Yeah, I hope you can see. Yeah. So now if theta equals to pi, then a dot b is equals to mod a into mod b cos pi. Cos pi means minus 1. Cos pi means minus 1. So we will write like this, minus of mod a mod b. Okay, minus of mod a mod b. This is number 4. Now number 5 we will be doing. So I am just rubbing this from here. I am rubbing. Number 5. Number 5 is this. For this application of 3, you can say theta equals to 0. That means if we are taking both the vectors same, that means a dot a vector, then we can write down mod a vector into mod a vector. Just we are applying this, because both vectors, if two vectors are equal vectors, then their internal angle is 0. So mod a vector equals to mod a vector, that means it can be written as mod a vector's whole square. Number 6 is an application of number 4. A vector dot minus a vector, and their angle between them is pi. So we can write down minus of mod a vector into mod a vector is equals to minus mod a vectors whole square. So we can write down these two also. Coming to number 7, there are three mutually perpendicular unit vectors I cap, j cap and k cap. For these three mutually perpendicular, I am saying that means I cap dot j cap equals to j cap dot k cap equals to k cap dot I cap will be 0, because they all are pairwise perpendicular, so it will be 0. And secondly, we can say I dot I equals to mod I dot whole square. Mod I dot means always 1. So 1's whole square is 1 because it's unit vector. Unit vector's modulus is always 1. So 1 square is 1. Similarly, we can say j dot j is equals to 1 and k dot k is also 1. So these are the preliminary observations, right? So I am rubbing the lower part. Coming to number 8. Number 8 is angle between, so theta is the angle between A and B. We know that A dot B is equals to mod A into mod B into cos theta. From this we can find out the angle theta. That means cos theta will be A dot B divided by mod A mod B. Or you can find out theta equals to cos inverse A dot B vector divided by mod A vector mod B vector. Okay, so this way we can find out the angle between the vectors A and B. And the last observation of dot product is, suppose number 9, this is A dot B equals to mod A mod B cos theta. Somebody can write down mod B mod A cos theta, right? Because mod A is the real number, mod B is the real number, so real numbers multiplication in real number set is commutative, so we can write down anytime mod B into mod A. Now from this we can write down this is B dot A vector. So ultimately we are getting A dot A vector dot B vector is equals to B vector dot A vector. So we can say that dot product is commutative. Now this is all about today's session, students. I hope you have understood it, and I know that this is very easy, but you need to practice on it. And mathematics is all about practice, practice and practice. So okay, we'll meet in the next video with any other topic. Till then, bye bye and have a good day.